Hello, welcome to DevCamp. My name's Chris, and in this session we're going to talk about all the cool things that Meadow Windows brings to the table. First, let's talk about what Meadow Windows is. Basically, it's the same stack that you're used to. It's a Meadow core stack with an implementation for Windows Desktop. What this means is it allows you to use Meadow drivers like Meadow Foundation and anything else that you've developed, and it allows you to do much faster debug and prototyping of applications. Meadow Windows is extremely similar to the F7. It has a different app generic parameter. You see here the Meadow app derives from app, but the generic parameter is Windows. When you build the application, you actually build it as an application as opposed to building it as a library, which you do for the F7. You also should target .NET 7. 6 is fully supported, but all of the samples are written for .NET 7. And lastly, you have to have an explicit main entry point. The reason for this is on the F7, the OS launches Mono, and then Mono automatically calls into Meadow OS for you. On the desktop, this is not the case. The runtime does not know that you're launching anything with Meadow, so you must call Meadow OS start yourself. So why Meadow OS? There are at least 3 use cases for it. We'll cover 3 here, but I'm sure people are going to come up with other uses that I've not even thought about. The first one is for prototyping MicroGraphics libraries. So if you've got an application and you're using MicroGraphics on an F7, deploying, debugging, it tends to be a long iteration process. That development cycle that from change, deploy, test, debug tends to be very long because you're deploying application binaries down to the device. If you're running on the desktop and you're running Meadow Windows, the turnaround is near instantaneous. It is all running on your desktop, so you have the familiarity and the speed of immediate turnaround and being able to set breakpoints, do all of the things that you do on debugging a desktop application. Let's take a quick look at a demonstration of how this works. Here we have a Meadow Windows application. You can see that because we're targeting Windows. And what we're using here is we've got a WinForms display. This is a display that targets WinForms and implements the iGraphics display interface from Meadow Foundation. So it acts just like an ST7789 or any other SPI-based display that we have support for. We also have MicroGraphics here, and MicroGraphics takes in a display when it's created. So let's come down and take a look. We create this WinForms display, and then we pass that display into MicroGraphics, and from that point on we can use MicroGraphics just as we would for something running on the F7. The nice thing here is I can set a breakpoint, say here, then I can use the standard tools to step through, and you can see it's very, very responsive. I can hit run, comes right back as fast as I want to. So much, much faster than debugging on the F7. I can hit stop, hit run again, and I'm right back at that breakpoint. So the turnaround time for making changes and re-debugging is much, much faster. So now if I just let the application run, here it is here. So we've got a display that implements the iGraphics display. It behaves just as it would on the device on an F7. Obviously, performance is going to be way different between here and a device, but all of the code is directly portable. A second use case for Meadow Windows is for driver development. If you need to develop a driver that uses GPIO or I2C or SPI bus, you can use an I/O expander like the FT232 or Silicon Labs CP2112. They plug into the USB port on your PC and then provide an extension for that I/O. Since Windows devices don't have inherently GPIO, you don't have a pins collection on the device. Instead, you instantiate one of these devices and then use that as your I/O. Let's take a look at how you would use one of these in an actual driver. So here's a little bit of a contrived sample. Let's say we're developing a driver for a Mac 7219 display. I've got that sitting here, a 7219, and then this is my I/O expander. So let's say I have the driver and I've written it and I run it. And I notice we've got quite a bit of tearing on here. From experience, I know that that's likely because I'm driving the display too fast. So I come over here, stop running, change the default speed, and run again. And now you can see the tearing has gone away. And that's how fast it is to make a change and redeploy. It is much faster than if we have to do it to the F7. And this is just a SPI device here, connected right up to the FT232. The third use case that I can think of for Meadow Windows is for building human-machine interfaces, or HMIs. Basically, if you have a desktop application and you want to add access to hardware peripherals, this might be done via Avalonia, which gives you a cross-platform UI, maybe WPF or MAUI, or even a WinUI 3 app. Basically, if you've got a desktop application, but you want to add access to some physical hardware, you can do that through Meadow Windows. Let's go take a look at an Avalonia sample. So here I have a class called an Avalonia Meadow application. This derives from the Avalonia application and implements the iApp for Meadow. So basically it's a combination of Avalonia and Meadow. Most of the implementation here is just returning a completed task. The important piece here is that you'll see that Meadow OS is started in a background thread. We'll also revisit this exact same sample in Meadow Linux later on today. Meadow OS starts up, and the entire stack with all of the driver access and things that you're familiar with from Meadow immediately become available, and you are now running inside of an Avalonia app. So inside of our app XAML, we create our FT232 I/O expander, and from it, we create a digital output port. We will connect that to an LED. For the view, something really simple. We had a much better example yesterday during the keynote. The idea here is just to show you that direct hardware interaction. So we've got a button. That button is bound to a command back in our view model. And in the view model, our command, which is defined here, is a reactive command that calls toggle LED, which simply changes the state of this LED. The LED came from the resolver, which is a DI container that we have in Meadow. And so all we're doing is we're turning on and off the state of that output, which will in turn turn on and off the LED when we click the button. Then if we run this application, you'll see, very simple button. We click on it, and the LED on the system turns on and off. Obviously, you could do much more complex things, but this shows that you've got direct integration between a UI application running on Windows and hardware managed by the Meadow stack. So there you have it, 3 really solid use cases for using Meadow Windows to improve and speed up your development and prototyping of your applications, Also, even extending existing applications to use hardware. If you've got any questions, go ahead and leave them down in the streaming service that you're using. We'll try to answer them. Otherwise, I hope you have a good conference. Thanks.